We introduce ClusBridges, a visual analytics system to abstract, summarize, and present a large size of travel records, from general observations to local details. At the macro level, the system clustered travel records into groups and divided the entire city into multiple regions to summarize overall city life patterns. At the micro level, we highlight an individual's daily patterns with interesting details illustrated. Based on the map and travel times taken to all locations, we divided the city into 15 regions, labeling them from A1 to F4. The ancient Chinese bridge was an inspiration for our design. ClusBridges uses bridge-like arcs to visualize the volume, speed, and direction of traffic from one node to another. Then, it clusters travel journal data to better identify life patterns for each individual. Major components of ClusBridges are the traffic of locations and regions, routines of clusters and individuals, and trends and metrics of traffic. The bridge-like arcs reflect two-way traffic patterns from one location to another, using the convention of right-hand traffic. The width of the arc indicates the volume of traffic from one node to another. The colors distinguish weekday traffic from weekend traffic. The arc's curvature and dashes indicate the speed, calculated by the Manhattan distance of two nodes divided by their average travel time. The straighter the arc, the faster the speed is. ClusBridges clearly shows that the traffic patterns between regions vary with time. We can see that during the weekdays, traffic rush hours occur around 7 a.m. and 4 p.m. Traffic from A1 to C2 is smooth, but traffic from B1 to A1, C2 to B2, and C2 to D3 are generally slow. By selecting different destination types, we can see when and where people travel from each region. Typically, people travel to nearby pubs and restaurants on weekdays and travel to remote regions on weekends. By filtering building types, weekdays, hours, and months, the users can easily view traffic patterns between different buildings. We clustered travel logs into life routines and verified these clusters with a UMAP technique. For each life routine group, we provided detailed travel destinations and statistics about time and stay duration. For example, one routine cluster is from the workplace to the restaurant during lunchtime. Another cluster is a group of drinkers that go to pubs during weekday evenings and any time on weekends. Participants with similar life routines are then further classified into 7 groups. For example, one group could be regular workers that on weekdays go to work in the morning, eat lunch at nearby restaurants, go to pubs after work, and return home to rest. On weekends, they regularly go to pubs. We can observe patterns from every participant, including details of their travel locations, preferred pubs and restaurants, employers, and durations of stays at each location. These maps help cluster and partition into bigger regions. By filtering by building types and other criteria, we can visually measure the busyness of different locations. For example, we can roughly infer which area is the busiest based on point distribution. Let's look at participant 9's life patterns. On weekdays, he commutes between his apartment in Sector F2 and his workplace in Sector E3, and he always eats at the same restaurant. On weekends, he goes to eat at a different restaurant and usually visits at least one of his 5 favorite pubs. Participant 101 has a similar weekday routine as participant 9, but prefers to stay in his apartment and go out for occasional meals on the weekends. We can see many different lifestyles in the city. As the cursor moves along the navigation bar, various lifestyles show up. Through navigating ClusBridges, we can view life routines and their clusters, read an individual's life details, and understand city changes and trends.